Hi everyone, today we'll be looking at the November 2020 paper 3 calculator paper of the GCSE 91 syllabus. Question 1 is starting off with simplifying n cubed times n to the power of 5, and of course I'll be adding up the indices to give me n to the power of 8. And then to simplify c cubed d to the power of 4 over c squared d, I will be simplifying c cubed with c squared to give me c, and d to the power of 4 with d to give me d cubed in the numerator. So cd cubed is the final answer for part B. C is an inequality. I will start off by cross multiplying by 2 to get 5x is greater than 14. Then if I divide by 5, I get x greater than 14 over 5. Question 2, Andy cycles a distance of 30 kilometers at an average speed of 24 kilometers per hour. He then runs a distance of 12 kilometers at an average speed of 8 kilometers per hour. We need to work out the total time Andy takes. Obviously, I should be referring to the formula that says that speed is distance over time. And we've got the time taken while cycling and the time taken whilst they're running. So we know that the speed is 24 kilometers per hour, and that is equal to the distance of 30 kilometers over t1, which is the time spent cycling. So 24 t1 is 30, leading to t1 being 30 over 24. And then I'll do the same for the running distance. I'm going to say that 8 kilometers per hour is 12 over t2. So 8 t2 is 12, leading to t2 being 12 over 8. Now if I add t1 and t2, I'll be getting the total time of the journey. I'm just going to throw everything on the calculator, and this is giving me an answer of 2 3/4. Now, we have been specified to give our answer in hours and minutes. We know that a quarter of an hour is 15 minutes. That means that 3/4 is 45 minutes. So the answer should be 2 hours, 45 minutes. Question 3, it's a number m rounded to 1 dp. The result is 9.4. So we know that this quantity m is 9.4, correct to 1 decimal place. I go 5 up and 5 down to find the boundaries, the error interval. So that's going to be 9.35, 9.45. Question 4 is about Mezi that knows that she needs 3 kilograms of grass seed to make a rectangular lawn 5 meters by 9 meters. Now the seed is sold in 2 kilogram boxes, and she wants to make a rectangular lawn 10 by 14 meters. So she has 5 boxes of grass seeds. I will start by saying that a 3 kilogram of grass seed will cover 5 times 9, which is 45 square meters. So we need 3 kilograms for this area, which means that 1 kilogram should be enough for 15 square meters. And since the grass seed is sold in 2 kilogram boxes, I'm going to say that 2 kilograms will cover 30 square meters. Now the lawn we want to cover is 10 by 14, so 10 times 14 is 140 square meters. And so if I divide 140 by 30, I get 4.67. So we need 5 boxes. So she has 5 boxes, therefore I can conclude that Maisie has enough grass seed. In part B, we're being told that she proceeds in opening the 5 boxes. She finds out that indeed 4 of them contain the 2 kilograms, but one of them only contains 1 kilogram of grass seed. Does this affect whether Maisie has enough grass to make her lawn? So we have a total of 4 times 2 plus 1, which is 9 kilograms of grass seed. If I multiply this by 15, which is the area covered by 1 kilogram of grass seed, I get an answer of 135 square meters. This is less than the required area of 140 square meters, and therefore I can say that there is not enough grass seed. Question 5, we've got two fair three-sided spinners, so 1, 2, and 3 are equally likely to appear. I'm being asked to complete the probability tree diagram shown here. The probability lands on 2 is obviously a third, and 2/3 of not being 2, and exactly the same thing is repeated here since the two spinners are indeed identical. Now we need to work out the probability that A lands on 2 but B does not. So I want to end up here. As I travel through the probability tree diagram, I multiply the probabilities I encounter. So I'll be doing a third times 2/3. So the answer for part B is 2/9. Question 6, we are being given this pair of straight lines. We need to use the graph to solve the simultaneous equation. It's obviously the point of intersection here, -2, 4. So I'm just gonna write down the solutions. And then here, we're being asked to use the graph to find the estimates for the solutions of the quadratic equation x squared minus 4x plus 2 is 0. One solution is here, the other is here. The reason is whenever we've got something equal to 0, we're essentially asking for points of intersection with the x-axis. So I can see that this one here is 0.6 and this one here is 3.4. So these are the two solutions that stem from the graph. Question 7, we've got a total of 45 boys and girls, and the mean of the boys, of the 18 boys, is 16.2 years, and the mean of the 27 girls is 16.7 years. We want to calculate the mean age of all 45 boys and girls. So I will start by saying that those 18 boys with an average of 16.2 years have a total age of 18 times 16.2, which is 291.6. For the girls now, it's 27 girls times 16.7, that's the mean age of the girls, which is 450.9. If I add the 291.6 and the 450.9, I would have found the total ages of the 45 boys and girls. So if I divide by the total number of children or students here, 18 and 27, and plug this on the calculator, I get an answer of 16.5. In question 8, we've got some counters in the back. The table shows the probability that the counter taken at random will be blue or will be green. It could also be red or yellow. And additionally, we are told that the probability that the counter taken at random will be red is 5 times the probability that the counter will be yellow. So that means that if I put an X for yellow, I should be putting a 5X for red. We've got a total of 300 counters in the bag. Work out the number of yellow counters in the bag. I will start by finding the value of X. So we know that the sum of the probabilities should be giving me a result of 1, because it is certain that one of these colors will surely show up. So 0.52 plus 6x is 1. 6x is 0.48. So x is 0.08. In other words, if I think of this as percentages, 32% of the counters are blue, 20% of the counters are green, 8% of the counters are yellow. So if I multiply the proportion of yellow counters by the total number of counters, I will find the actual number of yellow counters, which is 24. In question 9, we're being given a prism, and the cross section of the prism has exactly one line of symmetry, and we're told to work out the volume of the prism. Now we know that the volume will be the cross-sectional area times the length. And the cross-sectional area is essentially consisting of this rectangle here, and then it's this triangle. Now, if I concentrate on the triangle and extract it here, I know that this is 40 degrees. The fact that it has one line of symmetry, the cross-section, means that this is an isosceles triangle, and I know that all of this is 10. So if I drop the perpendicular here, I could call this h, and this will be 5. Now, tan of 40 is h over 5, and therefore 5 tan 40 is h, that's the height of the triangle. So if I revisit the formula here, the cross-sectional area is the area of the rectangle, which is 12 times 10, plus the area of the triangle, which is a base of 10, times a height of 5 tan 40 over 2, and all of it times the length of the prism, which is 20 centimeters. Now I can plug this everything as it stands on the calculator, and I get an answer of 2,820 cubic centimeters. Question 10 says that a person's heart beats approximately 10 to the 5 times each day, and the average person is expected to live for approximately 81 years. We're being asked to work out an estimate for the number of times the heart will beat in a lifetime. So we've got 81 years times 365 days. I'm ignoring the presence of any leap years, times 10 to the 5. I plug this on the calculator. I get 29565 followed by 5 zeros. Well, I had to give my answer in standard form, correct to 2SL, so I'm first gonna go to standard form. It's gonna be 2.9565, and the decimal point was here. It's been moved 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So that's gonna be times 10 to the 9. The only thing missing is the rounding to 2SF, which has to be 3.0 times 10 to the 9. Part B, 2 times 10 to the 12 red blood cells have a total mass of 90 grams. And what's the average mass of one red blood cell? So 2 times 10 to the 12 is 90 grams. And the question is, one of them, how many grams? I will cross multiply to say that x is 1 times 90 over 2 times 10 to the 12. I put this as it stands on the calculator, and I get 4.5 times 10 to the minus 11. And that's grams. In 11, we've got P on a grid, and it's rotated 380 degrees about the origin to give triangle Q, and then Q is translated by 5 minus 2 to give triangle R. So I will start by doing the rotation. Remember that in the exam you are indeed allowed to have tracing paper, which is certainly useful. So if I do the rotation, I will find that Q is gonna be here. So this will be the position of Q. The center of the rotation was the origin. So this is Q. And now I will translate this by 5 minus 2, which means I will go 5 to the right and then 2 down. So this will take me at this place here. And that's the position of R. I'm being asked to describe fully the single transformation that maps P onto R. So looking at this, the orientation has changed. It has to be a rotation. I could actually join together corresponding points. It's easy to see that if it's a rotation, it's 180 degrees. And if I join together corresponding point, it's clearly the case that the center of the rotation is here. So it's a rotation about 2.5 comma minus 1, 380 degrees. Now 180 degrees does not need a direction. It's the same, either clockwise or anti-clockwise, but it's good to note that an alternative would be an enlargement, scale factor minus 1, center 2.5 minus 1. These two are equivalent in this case. Under the transformation, there is a point that remains invariant, which means it does not change. If I'm rotating, the only point that does not change is the center of the rotation, 2.5 comma minus 1. It's an algebra question. We need to express this as a single fraction. I will start by identifying the LCM of x plus 2 and x minus 4, which is simply the product of the two. So this means that x over x plus 2 plus 2x over x minus 4 will be expressed over the same common denominator of x plus 2x minus 4. Now, the first fraction here, the denominator has x plus 2, it's missing the x minus 4, so that's what I need to multiply it by. And similarly, the second fraction is missing the x plus 2, so this will be x minus 4 plus 2x, x plus 2. Notice that I'm not doing too many things in one go. I have a simple objective here in this line to express everything over the same denominator. It's a common mistake for students to try and expand at the same time, and then they start messing up with the negative numbers and when they expand and all of that. So this will be x squared minus 4x plus 2x squared plus 4x, all of it over x plus 2x minus 4. I've been asked to give it in its simplest form. The minus 4x with the plus 4x go away, so I'm left with 3x squared over x plus 2x minus 4. In part B, we have to expand this triple set of brackets. So I will start by expanding the first two brackets. X times 2x is 2x squared. X times 3 is 3x. Minus 3 times 2x is minus 6x. Minus 3 times 3 is minus 9. And 4x plus 5 is still there. I will collect like terms in the first bracket, 2x squared minus 3x minus 9. And 4x plus 5. And now I'll do a further expansion by considering all the possible pairs. So it's going to be 8x squared plus 8x cubed, plus 10x squared minus 12x squared minus 15x minus 36x minus 45. And I'll collect like terms to give me 8x cubed minus 2x squared minus 51x minus 45. Question 13 is about shading and inequalities. We need to shade the region satisfying all these inequalities. The first thing I notice is that we've got 4 inequalities, so I expect a 4-sided region. I'll start with the easy. lines x is 0, that's what I'm considering, and x is 2. They are both perpendicular lines, so this is x is 0 and we also have x is 2. Now for y being less than or equal to x plus 3, I will consider y equals to x plus 3. When x is 0, y is 3. When y is 0, x plus 3 is 0, which means that x is minus 3. So I've got the 2 points through which we cut the axis, and I can draw the line now. So it's gonna be something like this. So this is y equals to x plus 3. And for the last one here, I will be considering 2x plus 3y equals to 6. When x is 0, 3y is 6, so y is 2. When y is 0, 2x is 6, so x is 3. So again, I have the points through which I cut the x and the y axis respectively. So I can start by cutting through 2 and minus 3. So this is the line 2x plus 3y equals to 6. Now let's consider the inequalities for a moment. So we have that x should be greater than or equal to 0, so to the right. X less than or equal to 2, so to the left of the line. Y less than or equal to x plus 3, so I'm below. And for the final one, 2x plus 3y greater than or equal to 6, so we are above the line. So it's easy to see that the region being satisfied by all 4 inequalities is this one here, which I have to label with R. In part B, we've got the diagram showing region S that satisfies the inequalities shown here. And we've got Geoffrey, which says that the point with coordinates 2, 4, which is just here, does not satisfy the inequalities because it does not lie in the shaded region. Is Geoffrey correct? We need to give a reason to justify our answer. So the problem is that the point lies on the boundary. This line here is the line x plus y equals to 6. And because the inequality here is inclusive, it's less than or equal to 6, it means that the boundary forms part of the region S. So actually 2, 4 is indeed within the region, so Geoffrey is not correct. So is Geoffrey correct? The answer is no. And I would say that since the inequalities are inclusive, 2, 4 satisfies all 3 of them. Including x plus y less than or equal to 6. Question 14, we've got a circle and the points B, D, E, and F lying on the circle, and then the line ABC is a tangent. We're being asked to find the sides of the angle ABD, which is the angle here. I start by observing that I'm dealing with a cyclic quadrilateral, so I can immediately say that DBF is 180 minus 100, which is 80 degrees. The reason is that opposite angles of a cyclic quadrilateral add up to 180 degrees. I've been asked to give reasons. And then I notice that now that I know the angle here is 80 degrees, I can go a step further and find this angle here, BFD, which is the third angle of the triangle. So BFD is 180 minus 80 plus 40, which is giving me an answer of 60. The reason is that angles in a triangle add up to 180 degrees. And now that I know that this is 60, I keep updating my diagram as always. I notice that this being a tangent and the chord here, we've got the alternate segment theorem. The angle ABD and the 60 here are equal. So ABD is 60 degrees, and the reason is alternate segment theorem. Next, question 15, we need to prove algebraically that 0.73 recurring can be written as 11 over 15. Now the dot over the 3 means that the 3 keeps repeating. 7 does not form part of this repeating pattern. So I will start by letting x be 0.7333. Multiplying by 10 gets the 7 out of the way. And then I will multiply again by 10, so 100x is 73.333. And the good thing here is that I've got the same decimal part, which means I can subtract one from the other. 100x minus 10x is 90x, and 73 minus 7 is 66. So x is 66 over 90, which simplifies to 11 over 15. As required. In question 16, we're being given the speed time graph for a car, and we need to work out an estimate for the distance we've traveled in the first 30 seconds. Now, we know that in a speed time graph, it's the area under the graph that gives me the distance. Now, this being a parabola means I cannot find exactly the value, but what I can do is say I'm interested in this area here, and I could draw this triangle, which should give me a good estimate to the area. I notice that the height is 9, the base is 30, so I will simply do 30 times 9 over 2, which gives me an answer of 135 meters. Now, is your answer to part A an underestimate or an overestimate of the actual distance? And give a reason for your answer. If you look at the triangle in comparison with the curve, there is some area we are missing out, we haven't been able to capture. So this is area missed, and therefore we got an answer which is less than the exact value, so it's an underestimate. So I could say it's an underestimate, and the reason is that the curve bends outwards. And then Julian used the graph to answer this question, work out an estimate for the acceleration of the car at time 60 seconds. Here is Julian's working. So he did speed over time, he did 13 over 60. So let's go back to the graph. We want to find the acceleration at t60. So we know that in a speed time graph, it's the gradient of the graph. But what Julian did is that they have considered this gradient here, which is wrong. What they should have considered is the gradient of the tangent here. That would have been the acceleration at t is 60. So they are actually wrong. So the explanation is that Julian should have drawn the tangent at 60 seconds. 17, it's the histogram showing information about 80 competitors. And then we're being asked to calculate an estimate for the mean distance. Now, looking at this question, I'm trying to bring it to more familiar ground that would allow me to calculate the mean distance the way I'm used to. So I observe that we've got 1, 2, 3, 4 classes. And this is distance. So I'm just gonna say distance. It's 6.4 to 7.2. Then 7.2 to 7.6. Then it's 7.6 to 8. And then 8 to 8.2. Now from the histogram, I can read the frequency density, which is 10, 50, 100, and 60. And I could also fill in the class width, which is the difference between the limits of each class. So the 6.4 to 7.2 is spanning a distance of 0.8 meters, 0.4 for the next class, 0.4 and 0.2. So the frequency now is simply the frequency density times the class width. So 10 times 0.8, which is 8, 50 times 0.4, which is 20, 100 times 0.4, which is 40, 60 times 0.2, which is 12, a total of 80. And then I include the midpoint. The midpoint of 6.4 to 7.2 is 6.8. 7.4, 7.8, and 8.1. So the mean will be the product of frequencies and midpoints. So 8 times 6.8 plus 20 times 7.4 plus 40 times 7.8 plus 12 times 8.1 over a total of 80, which gives an answer of 7.645. In 18, we've got a cube. We're being told that AH is 11.3 to the nearest millimeter. This is AH. So 11.3 centimeters is 113 millimeters. So if this is to the nearest millimeter, it means that the upper bound has to be 113.5 millimeters and the lower bound 112.5 millimeters. Which means that in centimeters, it's 11.35 centimeters for the upper bound and 11.25 centimeters from the lower bound. Now we need to calculate the lower bound for the length of an edge. So I will call the length of an edge x. So this is x and this is x. I will draw the diagonal here. And if I call the diagonal FHY, it's easy to see that x squared plus x squared is y squared. So 2x squared is y squared. And then we've got a second right angle triangle here. So x squared plus y squared is 11.25 squared. I'm using the lower bound to find the lower bound for the length of the edge. I will replace y squared with 2x squared. So x squared plus 2x squared is equal to 126.5625, which is 11.25 squared. 3x squared is equal to that. I will divide by 3 to get that x squared is 42.1875. And if I take the square root of that, I will be getting an answer of 6.49. 6.49519. So to 3SF, this would be 6.50. Question 19, it's a regular hexagon ABCDEF with side lengths x. So this here is x, all of these are x. And it's then enlarged by a scale factor of p. I need to show that the area of the shaded region is given by this expression here. So I will start by finding the area of the small hexagon. If I draw the diagonals like this, we can notice that we've got 6 equilateral triangles formed. The reason that they are equilateral is that these are surely isosceles. The 6 angles here add up to 360 and they are all the same, so this must be 60 degrees. So this is also 60 degrees and this 60 degrees, and therefore the sides are x. So I can easily say that the area of triangle of hexagon ABCDEF will be 6 times the area of a triangle. The area of the triangle will be a half times x times sine 60. Now sine of 60 is root 3 over 2. So this is 6 times a half x squared root 3 over 2. The 2 with the 6 leave me a 3. So I get 3 root 3 x squared over 2. That's the area of the small hexagon. And now the area of hexagon GHIJKF, I'm gonna use the fact that one is an enlargement of the other by a scale factor of p. So if I enlarge something by a scale factor of p, it means that the area is being enlarged by a scale factor of p squared. So it's gonna be p squared, what we got above. This means that the shaded area is simply one minus the other. So it's gonna be p squared 3 root 3 x squared over 2 minus 3 root 3 x squared over 2. I notice that 3 root 3 x squared over 2 is a common factor, and I'm left with p squared minus 1 in the brackets as required. Question 20, we're being given a list of 5 numbers. What is the lowest common multiple? Well, the lowest common multiple, for it to be a multiple, it should be at least as big as the greatest of these. And the greatest of this is the one with the highest power, 98 to the 91. Equally, someone could ask for the highest common factor, which would have been the smallest power here. In question 21, we're being given that 5c plus d is c plus 4d, and we need to find the ratio c to d. So I will start by saying that 5c minus c is 4d minus d. So 4c is equal to 3d, leading to c over d is 3 over 4, and therefore the ratio is 3 to 4. And then in b, 6x squared is 7xy plus 20y squared. Both x and y are positive. I'll collect everything on the left hand side. 6x squared minus 7xy minus 20y squared is 0. I can factorize this into 2x minus 5y and 3x plus 4y, which leads to 2x minus 5y is 0, or 3x plus 4y is 0. Now, for the factorization, it takes a bit of experimentation to get the right split with the 2 and the 3 and the minus 5 and the 4. But once you get it, it's fine. Now 2x minus 5y is 0, so 2x is 5y, or 3x is minus 4y. Now, x over y here is 5 over 2, and both of them are positive. Here, if you look at it, if x is positive, y must be negative. And if x is negative, y must be positive, which violates that both of them has to be positive. So I reject this scenario here, and therefore the ratio of x to y is 5 to 2.